Counting. Math without counting is like music without sound, video games without a processor, or drawing without creativity. This foundational element relies on our human ability to name abstractions. The assumed simplicity is possibly the reason that most never revisit the subject after elementary school. However, counting is also foundational to science, art, music, writing, video games, and more. It provided inspiration to shape our culture, dreams, religions, and stories. When applied creatively, counting can shift perspective and foster human connection. Beginner level. This stage is really about recognizing and repeating sequences of numbers. A beginner can understand the basic counting mechanics of naming quantities and placing them in order. They are also skilled at writing the symbols associated with each number. At this early stage, it's difficult to know if a novice is truly understanding the numbers or just memorizing them. To improve, count objects rather than symbols. Frequently, stories and movies have characters that resemble the symbol of a number rather than the quantity. This can lead to memorization rather than development of number sense. Try to prioritize number sense over memorization. Focus on groups of objects instead can help provide insights that the number is more than just the symbol or word. Less than or greater than. Given two or more piles of stuff, identify which is less than and which is greater than. Spend more time counting. Practice counting higher than you've counted before. Don't worry about starting from 1. Instead, count from the highest number you can think of and identify the next number. Focus on getting the underlying abstract concept rather than ensuring the word is right. Once you truly understand the abstraction, the exact wording can come later. Count backwards. Skip count. Sometimes we need to just move on and come back to the subject at a later time. Don't force it. You'll get it eventually. The average human lifespan is currently 72. You've got time to figure it out. Intermediate level. This level is all about finding ways to phrase questions associated with counting. Remember, questions arise naturally from counting regularly. Prior to the widespread documentation of arithmetic and modernization of mathematics, humans likely had their whole lives to explore counting. We expect most to replicate the information after a few short years. In the interest of speed, rather than exploring concepts organically, classrooms sometimes promote memorization of math facts. From my perspective, this represents perhaps the most significant failing of current mathematics education. It is these foundational elements that spark a natural curiosity of number theory. To gloss over them as we do today is a tragic reality. For example, humanity likely created arithmetic because they needed more efficient ways to count. Counting up from A is addition. Counting back from A is subtraction. Skip counting, A times is multiplication. Skip counting backwards, A times is division. A skilled counter will recognize the frequency of these patterns even before they may know arithmetic exists. To improve, consider the following questions. Can you count faster? What about faster than that? Is there a largest number? Is there a smallest number? Can you count to infinity? What about beyond infinity? Is it possible to have less than nothing? What is 0? What questions can you think of? Skip count forwards and backwards. What is the largest amount you can skip count by? Is there an amount larger than that? What about backwards? What is the smallest amount you can skip count by? Is there a smaller amount than that? What about backwards? Skip count forwards and backwards with offset. For example, 1, 3, 5, 7, 9, 11, 13 is skip counting by 2 with an offset of 1. 13, 11, 9, 7, 5, 3, 1 is skip counting backwards by 2 with an offset of 1. Advanced level. Depending on skill level, this section may feel intimidating. My intention here is to promote curiosity. As such, remember, there is no way of failing this course. Take only the useful information and leave the rest. The advanced level is born from the questions raised in the intermediate level. This level marks a move towards rigorous mathematical expression. The advanced level is a recognition that we can change number symbols and words if necessary. Therefore, we can choose what symbols and words represent the numbers. Our decimal system uses base 10 symbols arranged in placeholders to represent numbers. Computers count using 2 symbols, 1 and 0, and then store numbers in a variety of ways, including hexadecimal, base 16. Though the different ways of representing the number may look intimidating, they are identifying the same underlying concept. Each usage has pros and cons. Because numbers are abstract, we can reason with them without knowing the precise number. These are called variables and provide a solid introduction to algebraic concepts. This level of abstraction can make it challenging to see application. To improve, a reminder that this course is for non-math people. This advanced category requires significant mathematical rigor. Keep in mind that improvement tasks are optional. Look into how ancient tribes wrote numbers, from Babylonians to Egyptians to Romans, etc. Numbers have different meanings in different ways and look different in those individual civilizations. Write numbers in decimal notation. What might decimal notation look like in base 2 or 3? Practice converting numbers between different base systems, base 10 to base 2 or base 2 to base 10. Practice intermediate arithmetic problems. Do arithmetic in different base systems. Practice introductory algebra problems. Practice algebra in different base systems. Create your own number system. This includes audio words to say the number out loud. In English, we break consistency and have unique words for the first 12 numbers, not 10. We could easily remedy this if we said tenty, tenty-1, tenty-2, tenty-3 instead of 10, 12, 13, 14, etc. This includes new symbols to write the words down as well. Let the creativity flow. What do numbers feel like to you? What do they look like? Mathematician level. Mathematicians study counting extensively. Though I do not plan to provide a comprehensive list of everything mathematicians use counting for, I want to focus on fundamental concept that has provided significant advancements in mathematical understanding. Proof by induction. If we break counting down to its fundamental process, we can find unique, interesting ways to count. We can also identify things that do not have a counting feel. To do this, we need to consider a few core elements of counting the natural numbers. To start, consider the sequence of counting by ones. 1, 2, 3, 4, 5, and so on. The number 1 is a starting point and is required. Though we could start at 0, 2, 3, or 256 billion, the important thing to note is that 1 refers to the starting point. It's showing a beginning. 2 is a number that follows 1. Similar to 1 not always being the starting point, 2 doesn't need to be the next in the sequence. Counting by ones tracks similarly to traveling from A to B. The thing we need here is a clearly defined process to get from the first to the second. Though in mathematics this can look like an equation. Outside of math, this counting process could look like finding buried treasure, telling a story, mining for resources, or identifying what's missing in a painting. Mathematics is a rigorously defined process, but that doesn't mean counting outside of math isn't possible. It just means we need to allow slightly less rigor. In other words, squint your eyes a bit. The last piece of counting we are missing is, can we find the next one? The wording here is very intentional. With our given process, we need to identify a second beginning, aka the next one. If we can do this successfully, we have found a process that has an underlying counting abstraction. Mathematicians use proof by induction to prove that specific statements are always, sometimes, or never true. To prove something by induction, we show a beginning, assume the middle, and show that it works for the next one after the assumption. To improve. In creating a course for the non-math person, I will not provide any improvement materials for this level. If this or future topics feel engaging, perhaps you are more of a math person than you thought. I recommend rigorous math education.